So we are on composition of functions, and normally what you would see is it would look something like this or something like that. Okay, so for this one, let me clarify. It would sometimes look like this: g of x, and then there's that little circle in the middle, and then f of x. That's one way. Sometimes it would also look like this. Okay, that's an x. G of x, g, and then that little circle, f, and then they would have an x there. Okay, so that little circle right there is a composition of function, and of course we have the first one that I have seen shown in here. So you have g of something like that, and then inside your g, okay, inside the g is the f of x. Okay, so what is composition of function? Okay, so composition of function is just really a function within the function. So whatever is in the inside function, you will have to do that first and then apply the outside function after. Okay, all right. In this case, this is your inside function. In this case, the f is your inside function. So whichever is the function that's written last, that is the inside function if it's in these two types of format. If it's in this format, it's obvious that f of x is the inside function. Okay, so let's look at some of the um, let's try an example. Okay, so again, composition of function. Okay, so the first one, this is my first example. Let's say I say, what is f of g of x? Okay, so that's the question. So in here, your inside function is that g of x. So that's basically saying you copy the outside function first because this is the outside function, which is f of x. So I'm gonna say f of x, but instead of writing that x, I'm gonna replace that with parentheses squared plus 3. So the outside function of f, I'm gonna replace with parentheses every single time I see an x. I'm gonna replace that with parentheses squared plus 3. So pretty much everything is right, is the same. The only difference is that I replace the x with parentheses. And why is that? Because inside that parentheses, I'm gonna put my inside function, which is g of x. So this is the g of x. I'm gonna put that in here. Oops, should have been a, should have been able minus 1. Okay, so that is the f of g of x. Okay, now in comparison, let's try this. How about if this is the number? Okay, let's do that. This is number 1, and then let's say number 2 is this. Okay, let's say this is number 2. So you can see the difference. G of f of x. This is the second one. Okay, so in this case, the outside function is g, right? So what we're gonna do is we will write that equation first. Okay, so I'm gonna equal this, and it got me the g, which is 2, but look, there's an x. So every time you see an x, you will replace it with parentheses minus 1. 2 parentheses minus 1. And then inside the parentheses will be the f of x, which is that x squared plus 3. Okay, so those two are the difference. This is f of g of x. This is g of f of x. Okay, now of course sometimes your teacher might want to make sure that you simplify them. So it's just a matter of really doing the simplification. Like for number 2, this is just you distribute the 2. So now you have 2x squared plus 6 and then minus 1. Combining like terms, then you would have 2x squared plus 5. So this is g of f of x. Okay, now how do we do the other one? How do we do this? Well, this is x 2x minus 1 squared, so you need to square that one first, right? So that means 2x minus 1 times 2x minus 1, that's the square part, plus 3. And then now we will distribute this, so you will have 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is minus 2x. Negative 1 times negative 1 is positive 1, equal, oh, plus 3. Okay, combining like terms, so you have 4x squared. These two are the same. minus 2, not minus 2, y minus 2. Negative 2x minus 2x is negative 4x. 1 and 3 are like terms, plus 4. So this part right here, this is your f of g of x, okay? The other one is g of f of x. So it really matters which one function is outside and which one is inside, okay?